We build prototypes to give ideas shape and feel. But what if your material choice is secretly inflating your future costs by 10 times? This isn't from a major design flaw, but from a common early mistake: choosing materials on looks alone. Because from the start, the material you choose sets the absolute performance ceiling for your final product. Here, we'll show why production-grade materials are the core strategy for accuracy, funding, and market success. First, we're not talking about simple aesthetic models. We're focused on functional prototypes. A functional prototype must operate exactly like the final product, prioritizing technical performance. And for this to happen, they demand materials that behave identically to the final product under stress. Getting this right is statistically significant. Companies with systematic prototyping see a 63% higher success rate. So we know functional means using the right materials, but what does the right material actually control? Its impact is more than just strength. The correct material choice dictates precise dimensional accuracy after manufacturing. Properties like shrink rate and thermal expansion determine if your parts will fit together and work correctly. Material choice also governs how your product survives over time. Ignoring long-term aging effects is a critical error. Will it absorb moisture and fail, become brittle in the cold? A cheap prototype plastic offers no real answers. This is why the upfront investment in production-grade materials is a calculated move, not an expense. It's risk mitigation. So, how is this done in practice? One primary method is CNC machining, which ensures material properties are identical. For plastics, low-volume injection molding is another powerful tool. It replicates the exact mechanics and finish. These methods create prototypes you can put through genuine stress, heat, chemicals, heavy use, knowing the results are valid. This process gives you reliable technical data, but how does this translate into lower costs and faster timelines? The immediate benefit is foresight. These prototypes reveal true costs, but there's a greater advantage for funding. What is it? Now, it's not always practical to use the exact production material. The objective is functional equivalence. This means picking a prototype material that mimics critical properties you need to test, like fatigue life or chemical resistance. Another trap is ignoring scalability. A material perfect for one prototype might be impossible to manufacture at scale. This exposes a human factor: communication. Failures happen when design and production teams aren't aligned on materials. So it's a balance of material science, manufacturability, and team alignment. Getting this right provides the strategic benefits we hinted at. Remember that question about the ultimate payoff? It's investor confidence. A prototype made with production-grade materials is proof of manufacturability. It shows investors you've de-risked the project. This shifts the conversation from what if to when, demonstrating you understand real-world costs and processes. You're not just testing the part, you're validating the entire manufacturing process. That's how $1 spent early saves tenfold later. The materials performance ceiling and the manufacturing process aren't separate issues. They are two sides of product viability. Choosing the right material isn't just an engineering task, it's a core business strategy. So how do you apply this thinking? Stop treating prototypes as mock-ups. Treat them as version 1 of your product. Your material is a promise of quality to your customer. By using production-grade materials, you gain accuracy in testing, you remove downstream costs, and you build irrefutable confidence. Commit to a systematic process. Data shows companies that do have a 63% higher launch success rate. Iterate with materials that matter. What's the costliest material mistake you've seen? Share it in the comments. To learn more about material strategy, see the description. From raw material to finished product, the right choice is the foundation of success. Precision in prototyping means precision in the final product. With each iteration, failure rates drop and reliability increases. Successful validation under real-world conditions. Confidence secured from the engineering team to the final investor. Build it right from the start. Your material is your foundation.